Hello, Dennis.
George, how are you?
Hey, good. How are you? It's been a while.
It has been a while. It's nice to be talking to you again.
Yeah, good to catch up. Yeah, I should say that this is Dennis Overbye, New York Times Cosmic Affairs reporter. And you're in New York talking from the building on 8th Avenue, right?
That's right. Our well, not quite brand spanking new building anymore that we no longer own, but...
Right. Ever since the Troubles.
Yeah.
Yeah, and I'm George Johnson talking from my office in Santa Fe, New Mexico. So.
And how's the weather in Santa Fe?
Oh, it's nice, but it's been, we're really having a bad drought this year. It's like the worst in almost a decade, so that's kind of scary.
So you don't get any smoke from Arizona, is that?
Actually we did, last week and I guess that was the week before. I've lost track of how long that's been going on, but there were a couple of days that were really, really bad.
Yeah, really.
I mean, nothing like, what people were getting in Arizona, and I guess down in Albuquerque it was even worse.
Yeah.
400,000 acres or something like that. I mean, that's huge.
Yeah, I had a friend who was driving through Tucson a week ago, thinking of buying a house down there, but I don't know what whether he got scared.
Wow, Tucson.
I was looking for some. He lives in Oregon most of the year, so he's looking. He's
Who
looking for
lives in Oregon?
A friend of mine.
Oh, okay.
Yeah.
So
he's looking for someplace dry.
Tucson with a friend.
Yeah.
Well, that'd be a nice place to live. I mean, it gets pretty brutal, I guess, in August. And
I think you'd go back home to the Northwest in August, but yeah, there's a lot of intellectual life in Tucson. There's a lot of astronomers.
Oh yeah.
The desert is great.
It'd be great. Yeah. And there's a really great, like outside of Tucson, about 60 or 70 miles east, in Dragoon, Arizona, this place called the Amarant Institute that does archaeological research and seminars, and that's a pretty cool place. Right. It's kind of up a little higher than Tucson, so it's slightly cooler.
And there's a cave there that we went in a few years ago when we were out for mirror casting. I can't remember the name of it.
Oh,
it's
yeah.
A living cave where you have to go through an arrow.
Karchner?
Yeah, that sounds
Caverns
right.
Or something like that? Yeah, I saw that years and years ago. Actually, I was driving with Nancy, who I was married to at the time, out to Santa Barbara to be dropped off for my 3-month stint at the Kavli Institute there, with David Gross. And they were doing
when you were there.
Well, that was fun. Just hanging out with the superstring theorists for a while, and I got my own office and a bicycle, and I felt just like a sense of what it would have been like to have explored academia instead of journalism. But it's too late now.
It's never too late.
Well, I suppose not. Yeah. I was just thinking the first time not the first time I met you, but when I got to know you was when you came to the Times, originally as deputy editor of Science Times. These were back in Flusher days, and we used to have these summer retreats where the whole science staff, including people like Sandy Blakesley and I, who live on the other side of the continent, and they'd actually pay for us to come to New York, and we all hung out and talked. And I remember at the time I was kind of doing the superstring stuff, and I described my beat as the 4th through the 11th dimensions, which is, of course, what you're doing now. But I really liked how you described it. I saw this somewhere. You said you covered the cosmic affairs beat.
Yeah, I sometimes call myself the cosmic affairs correspondent, but I hope that nobody serious is listening when I say that. Because it does seem like an
you don't get to, it'd be nice if you got to. I mean, you got to go to Geneva a few times to see the Large Hadron Collider. But as the correspondent, they should be sending you on these interplanetary trips.
I agree, but although the Times has sort of regained its footing financially a little bit, they can't afford Andromeda. I mean, that's really that's tough,
I was recently reading about, remember Freeman Dyson and the Orion project?
Oh, yeah.
Yeah, well, they were going to use this. I guess it was going to be like a spaceship the size of like a Hyatt hotel and powered by exploding one nuclear bomb after another, and and by now, we would be exploring the solar system, and
we could, and we would have worked down our arsenal a little bit.
Yeah, so
politically,
it was interesting. Since Dyson was very much an arms control person.
Politically, it's difficult. Proposition. I was at a meeting just a couple of weeks ago where somebody said that I guess they using some surplus nuclear reactor, they could actually send a probe to Alpha Centauri within our lifetime. But somebody else pointed out that it was politically impossible to launch such a vehicle.
Oh, yeah, anything with a nuclear reactor in it.
Yeah, so that's
just
it
because
for that.
of like a space shuttle, except involving nuclear fissile material. Yeah, well, it's disappointing though that like me, you grew up, seeing Life magazine and the Saturday Evening Post, and they're all predicting, how we were going to colonize the moon, and that was, just kind of the small step to go see all these other places.
Yeah, these are disappointing times in some ways. I remember one astronomer, I think he was one of the Voyager scientists, who referred to his group as the cheated generation.
Ah, yeah.
We all grew up expecting to see people on Mars by now, and 2000. Some of the things that you saw in 2001. And it all the longer you live, the further into the future that those visions seem to recede.
Yeah, just the opposite of what it should be. Yeah.
I don't know whether these visions were oversimplified to begin with, or we've lost our daring as a species. We certainly lost the ability to affect any sort of political agreements on a large scale to do anything.
Yeah, it was such a. I guess first there was NASA just like turning to boring things like the space shuttle, and and then and then the cancellation of the superconducting super collider for exploring inner space, but that's kind of, I don't know. I mean, the LHC, the Large Hadron Collider, that's not as that's not as powerful as the superconducting super collider would have been, right?
No. So, are we in the official part of this now, or are we still just preliminary? Because I was saying we could talk about the LHC.
Oh yeah, we're live now.
A little bit because
yeah.
Because I was going to say there's at least some good news. We'd start out with some good news. Is that they announced the other day that they had produced one inverse femtobarn of integrated luminosity, which is how they keep track of particle accelerators keep track of their data. And one inverse femtobarn is about 70 trillion proton-proton collisions.
Oh,
so
okay.
That's a lot of data.
Wow.
And this is actually their goal for this year was one inverse femtobarn.
Yeah.
So they're way ahead of schedule for the year.
Wow, that's great.
In some ways, the collider is working very well. The detectors, these giant machines that are almost the size of the Times building, are working extremely well.
Wow.
On the other hand, it's only operating at half power.
Yeah.
It was as we know, it was supposed to be built to produce 7 tera electron volt protons, and they're only operating at 3.5 because a few years ago they blew out the connections between their magnets when they tried to step up the energy.
Yeah.
And so they're going to have to shut down in another 1.5 for a year to rebuild these connections, and they have another problem with their magnets that they don't even talk about it anymore. It's just that the magnets all start failing when they get up above 5.5 or 6 TeV.
Oh, wow.
Or at least a bunch of them. They don't even know how many have this problem because they haven't been able to get to these energies to test the magnets. So there are a lot of problems in the future. But in the meantime, it seems like things are going well. I mean, maybe better than you might have expected 2 or 3
Yeah, because there's been so
years
much
ago.
negative news. It's really nice to hear something good like that. And
so
and half power, does that put it at about what the Fermilab Collider does?
No, so
Like
so
when it's totally
Fermilab, the
maxed out.
Fermilab Tevatron, which has about 2 months more to live, was at basically 1 tera electron volt. So they're tripling the energy of the Tevatron anyway.
Wow, so that's significant.
Of course, the Tevatron still has, Tevatron has something like 7 inverse femtobars of data. So they're kind of way ahead in the piling up of data, but they're going to catch up fast.
Yeah.
So you hope that, or you would expect that something will come out of all of this. And as we know so far, it's just been rumors. So.
Yeah, it sounds like for a while you were just, every week you were chasing down another rumor that the Large Hadron Collider had found evidence of, was it the Higgs particle?
Well, so there was a rumor last summer that there might be evidence of the Higgs particle, but there's no evidence of Higgs particle yet.
Yeah.
The best data on the Higgs particle is from Fermilab, and their data is all about where it's not. So they're gradually gradually ruling out sections of the energy spectrum where the Higgs boson is not. And
yeah, that's kind of been the story. I mean, it's they look at higher and higher energies, and then they can say, well, it's not there, so therefore the mass of the Higgs has to be larger and larger. But you could just do that forever, right? If you don't find it, or at some point, will it get to where they'll say, well, theoretically, it's not likely to be, of an even higher mass, say, than the Tevatron can reach when it's running.
I think everybody agrees that if it exists, it's at a lower mass. They have a range, 120 or 115 to maybe 170 billion electron volts.
Okay, so at some point,
both the LHC and the Tevatron can produce particles of that energy, but because of the Higgs, it's very hard to find the byproducts. So if you produce a Higgs boson, it immediately decays into something else. And what if that something else depends on how massive it was to begin with, and there's all this background about this other things going on, and when you smash protons together, you're like smashing really dozens of different particles together at once, so they create big, messy explosions.
Yeah, then ultimately you have to get down to where you're measuring basically either electrons or photons.
Right. So that's why.
And then certain patterns and signatures and.
Yeah, or you're looking for B quarks if it's in some range, and you're looking for other particles if you're looking.
But those two, you end up seeing what kind of signatures they leave with electromagnetic radiation of some kind.
Yeah. So it's really a mess. It's amazing they think they can do it at all.
I know. Yeah, I know. I've said this many times before, but I think it's wonderful that grown men and women are still paid to do this kind of thing. It's a sign that some veneer of civilization is still intact.
It's true. It is. It's an enormous thing for our species to try to do, and it's really audacious. You think
it must have been amazing. I haven't seen the LHC, and you've been out there, 2 or 3 times at least, right?
Yeah, I've been there a couple of times, and I was there. The first time I was there, they were still putting it together, so actually I was able to climb around inside these detectors, the Atlas detector, which is about the size of the Eiffel Tower in some ways, and the physicists have to use mountain climbing gear, and they're all in harnesses and hard hats, and they're going up and down ladders inside this machine. And I was able to climb up right into the chamber where the protons actually collide. I have a picture of myself with my head right at that spot.
God, that must have been wonderful.
So, you can't do that now. In fact, you'll never be able to do it because now the thing has been running and everything down there is radioactive.
Yeah. Oh, sure. Yeah.
And but of course, meantime, the Fermilab is still going, and the Tevatron is still running for another few months. And I mean, lately, of course, the rumors have been out of the Tevatron.
Yeah.
So there was this bump in the data that this one group announced last spring, that with very high statistical significance, that could be a new particle that nobody had been expecting.
Right. Oh, yeah, I remember the story.
And well, it was sort of like, it was about 3 sigma or something like that, which is sort of physics talk for evidence of something, but not necessarily discovery of something.
Yeah.
And then a couple of weeks ago, this group, it's called the Collider detector. CDF anyway.
Oh yeah, so they built one of these giant detectors.
One of these giant detectors.
Yeah.
Anyway, so 1,000 physicists. And they had reanalyzed their data a couple of weeks ago and found that this bump was even more significant than they had originally reported. It was close to 4.8 sigma, which is, so 5 sigma is evidence of, is discovery of something, and you can start booking your flight to Stockholm.
Okay. Yeah.
But
so that would mean that it's like the odds that it was produced just randomly are just so vanishingly small.
Right, less than 1%. Maybe less than 0.1%. Like 99.7 or something like that. I figure that.
Yeah.
But then a couple of days later, the Arrival Fermilab collaboration called D0 announced their results. Mm-hmm. And they don't see a bump at all.
Okay.
So all this excitement just kind of deflated immediately.
Yeah.
And we were going to have a revolution in physics, and
beyond the
bloggers were saying when this sort of reanalysis of the data came out, this was the best evidence in the history of physics for phenomena beyond the standard model, which is this name that people have for kind of a group of theories that runs things in the universe today.
Yeah.
And, it would have been a glorious kind of, sunset for the Tevatron
Fermilab,
to do this, but, now it seems to have gone away.
Yeah, and I guess we should maybe explain that, like at Fermilab, you have 2 teams, and they each have built these completely different detectors, right, with different... So you have the same accelerator, but these 2 different teams running 2 different giant hotel-sized detectors that are each among the most complex things probably that people have ever made. So
right, and this is the way it's been done since they started building these big machines. That you always want to have 2 groups, 2 independent experiments going on, so that if one group finds something, the other group can check it, and vice versa.
Yeah. I don't think that comes out a lot when people read about these, because there's all this talk about not being able to replicate these huge experiments often, but actually that's exactly what they're doing. Just because you have one accelerator, you have these 2 completely different detectors, so it's like you're getting 2 different views on the phenomenon, and if they both see it with these detectors that were built according to different plans, it's going to seem pretty solid.
Right, and if only one sees it, then you've got a problem.
Then you wonder if it's a bug in the detector.
Get together, which CDF and D0 are now have agreed to, investigate this jointly and find out what was going on.
Yeah.
But if you only had one team, you would never know.
Right.
This was well, there's a good example of this in astronomy, actually, because 10 or 15 years ago, there were 2 teams of astronomers both using supernovas to try to chart the expansion of the universe.
Yeah.
And they both came out with this weird conclusion that the universe was speeding up. And if either one of those teams by themselves had said, I don't think it would have gone anywhere. But both teams, and they bitterly hated each other. And
and
some of the members still do. They're still fighting about it. If they hadn't agreed on this, it would have taken a lot longer for people to come around to this very bizarre result.
Yeah, because it's just suddenly I mean, you cover the stuff for so long and you get used to explaining how the universe is expanding, and then suddenly you have to say, well, it's actually accelerating, and then there's not just dark matter, but there's also dark energy, and
yeah, you have all this dark stuff, and it does sound kind of glib.
It does. Yeah, we're just kind of this frothing on the on the top of the wave.
So I get a lot of letters, and I'm sure you get them too, from people saying, isn't this kind of nonsense? Why are you postulating all these extra things to make the universe make sense? Doesn't this mean your theories are
yeah, you worry that it's like epicycles and Ptolemaic astronomy, and where you have to add these assumptions to make everything work. But then you start finding little ways to like cross-check, but it's all very indirect, obviously.
It's very, very, very indirect. Although now, I am bullish on dark matter.
That they'll find it at LHC.
I think that I don't know where they'll find it, but I feel this is one of these things that's due for a breakthrough. And because I've been following the various experiments. I mean, there are 3 different ways. I mean, should we explain what dark matter is? I mean,
yeah, that's probably a good idea.
So there is, going back really to the 1930s, there's this, this suggestion that there's more to the sky than you can see with your eyeballs, because the galaxies and galaxies of clusters are moving too fast. If all that was holding the cluster together was the gravity of what you can see.
Yeah.
And then in the 1970s, this astronomer named Vera Rubin was kind of charting the rotation patterns of velocities, and she found the same thing.
Yeah.
Galaxies were rotating much too fast if all they were.
So essentially they would fly apart and wouldn't exist if we had to explain it entirely in terms of the gravitational mass holding them together.
Right. So.
Yeah.
And so, a lot of studies like this concluded that galaxies seem to be embedded in these sort of big dark halos of stuff that we can't see. That in fact, there's about 7 times as much of this dark matter as there is visible matter.
Yeah.
This was a big problem for cosmologists.
Yeah, it's like 99%, it seems like at some point they were saying of the universe is like, in principle, undetectable except by its gravitational pull, or basically by inference. You could infer that this stuff was there, but it was, in principle, did not emit or absorb light, and that's how we detect stuff.
And in fact, they could imagine that there was as much there as they wanted in order to fulfill their various theories. They didn't know about the dark energy, but
this is before dark energy, and then it was already, it's just like, wow.
Dark energy kind of solved a lot of problems, but this the dark matter is interesting because it neatly fit into what was going on in particle physics at the time, that there were these theories called supersymmetry, which predicted predicted there should be all these other kinds of elementary particles that we just hadn't detected in our labs because they were too massive to be created yet, and they were unstable and had existed early in the universe but had died away. But there should be remnants of them floating in the cosmos, and about the right about the right number and mass to kind of fit the prescription for this dark matter. So the paradigms that there are.
So people are saying the dark matter is the same as these supersymmetric particles?
There are these clouds of subatomic particles whose identity we don't know yet, but if we could identify them, it would unlock a lot of mysteries of physics, and they're floating through us every day, every second actually. We just have to detect them somehow. So there are 3 ways to do that. As you said, they're trying to build them, trying to make them at the Large Hadron Collider. That's one of the big announced goals. And many people think they'll be easier to find than the Higgs boson for various reasons. Then there's cosmic ray experiments like the alpha magnetic spectrometer that just went up to the space station the other week, that are sort of looking for the effects of these things in the cosmos. But they're experiments to detect these things directly. Detectors underground to shield from cosmic rays and everything. At least
similar to the neutrino detectors,
right? Like the neutrino detectors.
Yeah.
And these experiments have been going on for 10 or 20 years now, but they're getting more and more sensitive, and they're recently have kind of reached the point where they should be able to see something if these particles are there.
Okay.
And,
so we might be converging both with these underground detectors that are becoming more sensitive, and then we have the higher energies of the LHC to maybe create the particles from.
Right. See, most people think that so you could make a particle at the LHC. That wouldn't prove that it is the dark matter particle. So you would want to be able to detect it out in space or passing through your body or your little germanium hockey puck that's in some old salt mine. And so there must be at least a dozen experiments going on in the world with all kinds of acronyms like CDMS and Xenon.
Oh, yeah. And there's like that one up in Minnesota, in the Sudan line. And they put them underground to shield out extraneous particles that would interfere with the data.
So there's been a lot of action in dark matter lately. There was much excitement 2 years ago when one of these experiments, CDMS, which is kind of one of the granddaddy of the experiments, actually was going to announce their final results, and there was a rumor that they had detected dark matter, and there was kind of a frenzy that day. And it turned out that they hadn't detected any more events more than chance.
Yeah.
In fact, people were pretty annoyed, actually, the secrecy surrounding the announcement afterwards. And so that turned the spotlight to an experiment called Xenon, which is in this Gran Sasso tunnel in Italy, which is probably the largest and best experiment. And they announced their first results a few months ago, and again, they didn't see anything. They didn't hype the announcement as much as the CDMS people did. Yeah. But in the meantime, there's an experiment also in the Gran Sasso, which must be the dark matter capital of the universe, an Italian experiment, which has been claiming for 10 years that they do see dark matter, but they can't say what it is, but they kind of see a modulation in they have these, I think it's salt crystals anyway. So they get a lot of ticks, and the ticks sort of rise and fall over the course of a year. And this is what many people have said dark matter would do, because as the Earth goes around the sun, it kind of goes into the dark matter wind and then out of the dark matter wind, and so there should be a modulation in your count rates. Yeah. The problem
then they're seeing this in Italy and not anywhere else?
Yeah, so they've seen this for 10 years, and everybody agrees that it's like 10 sigma or something like that this modulation is true, but nobody wants to believe that they're actually seeing the dark matter. One reason is because I guess their experiment is sensitive to very light dark matter particles compared to what the theorists say dark matter should be.
Yeah.
And this has actually made the Italian people quite unhappy. And if you go to their website, you see these kind of nasty comments there.
Really?
Yeah, they're very, very defensive. So there's been a battle going on. I guess
if it were too lightweight, it wouldn't really fit in with the idea of being supersymmetric particles?
Right. The supersymmetric particles, an average guess is like maybe that they have a mass of about 200 billion electron volts, which I think is, what, twice a proton or something like that.
Yeah, it's huge.
Whereas the particles...
Does this fall into what they call WIMPs, or weekly
these are
interactive massive
weekly interacting massive particles. Or WIMPs.
Okay, so if they're seeing something that seems to be much, much lighter than...
They are seeing
that wouldn't
things
fit
that
in with
we're down to like
hopes for getting supersymmetry.
5 or 10 billion electron volts.
Oh.
Apparently, if they're seeing anything at all.
Yeah.
But see, now there's a new experiment called Cogent, which is, I think that's the one that's in the Sudan mine.
Mm-hmm.
And they've reported that they also see a modulation.
Mm-hmm.
So it doesn't seem to be as strong a signal yet, but it agrees. I mean, it agrees in phase with the modulation the Italians see.
Yeah.
So these are very exciting times because this is kind of
that'd
this
be
is the first hint of
two of these mine experiments to start seeing something, and then could converge on it by creating the particles. But of course, again, if they're these weak particles, that's not going to be what they go for at LHC.
No, so the theorists are sort of jumping through hoops and trying to create all these elaborate scenarios about what could be happening on the dark side, as they call it.
Yeah.
Because so maybe dark matter isn't just one particle. Maybe it's a whole spectrum of particles. Maybe it's a whole. Look at the visible universe. It's a very complicated place.
Well, yeah.
We've got all these different particles. We've got these forces. We've got photons.
Yeah, this standard model describing like all these forces and the particles, and then when you look at it that way, it does seem kind of silly to say that there's going to be one dark matter particle.
I mean, that's what you start out hoping.
Yeah, right.
It's the drunk looking under the searchlight for his keys, right?
Right. Well, before you know it, then you have a standard model of all the dark matter particles and a standard model of the non-dark matter particles, and then you have to unify all of those. And
that's right. So, I mean, these models are starting to appear in the literature, which you have dark forces and, dark matter particles decaying other kinds of dark matter particles.
And,
so it's going to be
there's
really
so much
interesting.
depression. I'm getting from all this is there's so much going on beyond superstring theorizing.
I'd have to say I don't know how closely you follow string theory these days, but I haven't really written about it in years.
That's what I was thinking, and then there's all this other stuff going on that's it's actually accessible by experiment and observation.
Right. I mean, if you write about string theory, then it seems you wind up writing about the multiverse, and people are kind of tired of hearing about it. There hasn't been anything, as I can tell, as near as I can tell, anything that fundamentally new in string theory lately. But I mean, the action is down at lower energies where we can actually test it.
Yeah. And then once they go down and then bring back the LHC to its originally planned power, I mean, that could just open up all kinds of things.
We hope it opens up something.
Yeah. So basically they'll be looking for the Higgs, which is the particle that is posited to explain why all the particles we know about have this weirdly wide-ranging scattering of masses. So everything from the very lightweight neutrinos up to what is it, the top quark? Is that the heaviest quark? Or
the top quark is the heaviest quark, right? And apparently the top quark was surprisingly heavy.
Well, it's like a gold ion or something.
And
which is weird because then you think of these little particles like comparatively less massive particles like protons and neutrons, and they're made of combinations of quarks.
It is very strange, although not top quarks very often, right?
Yeah, right. Yeah, and then the whole question of why the neutron and the proton are almost exactly the same mass, but just slightly different. And this would all be explained by the Higgs, right? If there is a Higgs.
If there is a...
And if there's not, then... if there's not, then supersymmetry... There's like theories, Higgsless theories, right, that would explain all of this stuff using supersymmetric particles and other things that so far are just contrivances, but may exist.
Yeah, I'm sort of hoping, I'm kind of rooting for the Higgs because... Well, I always tend to root for the things that I've studied a little bit about, so that my investment will pay off.
Yeah.
I mean, there's something called Technicolor, which I think is
Technicolor,
a substitution for the Higgs.
Technicolor, we should probably say that, like in the standard model, the quarks are said to come in 3 different colors, quote unquote, and colors just being this way to refer to these different properties that they have that are somewhat analogous to electrical charge. They call it color charge.
Right.
And then there's this idea that beyond color there may be something called technicolor, and that this might might be part of some theory that would reduce all the forces to one and explain all the particles. And
right, and this was one of the things that was, when they found this bump in the Tevatron data last spring, Technicolor was a word that started coming up. But who knows? Maybe it will come up again.
Well, so we're going to have this period then when the Tevatron at Fermilab is finally taken offline after all these people's best efforts to keep it going, and then the LHC is going to be down while they get ready to bring it up to full power.
That's right. I hadn't thought about that, but there is going to be a sort of a year there when nothing's happened. Although, luckily, there will be a lot of data to analyze, so it won't be that dead year.
Yeah, it's funny with these accelerators, you like to think of these people and they're like sitting at some kind of scope and then suddenly, aha, it's the top quark. And then actually they're gathering all this data, and then it can take, weeks or months of number crunching with all the software to try to find this pattern in the data, and that's when you get to go, aha.
Oh yeah, it'll be going on for years. Well, it's sort of interesting, the whole interplay between the LHC and the Tevatron. Of course, they were hoping that the Tevatron would keep going.
Yeah.
And in fact, the LHC was originally supposed to shut down at the end of this year for its big overhaul. But they were sort of nervous, I think, about shutting down while the Tevatron was still going, because the Tevatron, as I said, does have this big lead in terms of the amount of data that they have accumulated. And so then they announced that they're going to keep going. And of course, then the Tevatron does have to shut down because we don't have the money to run it. And but so there's this rivalry, which kind of which is enhanced by the fact that it's the same physicists in both places.
Right.
So most everybody who works on an experiment at the LHC, or a lot of them also work on experiments at the Tevatron, and so they go back and forth, and people go back and forth between these labs depending on whether there's data, whether there's money to, whether they need to write a thesis or something like that. So there may be, so I think that they have been running into a manpower problem in Fermilab with people going to CERN now that's an up and going operation.
It was so interesting. A few years ago at our Santa Fe science writing workshop, at which you were an instructor once.
Once long ago, yes.
Yeah, we'd love to have you back. But we had a student, and he was one of the you know, the blue collar guys that works down in the trenches at the Tevatron. And, you know, the kind, you know, they go to work with their lunch boxes, and you know, they actually run the machinery, and it was just so interesting to get that perspective. Instead, you know, usually I'd talk to theorists and sometimes to the experimenters, but to the actual people. It kind of reminded me of that old, I think it was an Elton John song about, you know, the guy going out in space, and it's just a job, 5 days a week.
Oh, no, which song was that? Because I was just...
Oh, well, Rocket Man.
Rocket Man. I love that song. I was at an Elton John conference sort of a couple of months ago when he did it. Yeah.
Wow.
Yeah.
So it reminded me of that, and this guy was telling these stories. I think there was one incident where they thought they had gotten some kind of bump in the data, and it turned out to be an aberration caused by a seismic event on the other side of the world.
I can believe that.
Yeah, it was just, I wish I could remember the details, because it seemed like it would have made kind of a nice story, but it never got around to it. And I think he was going to work on something on that.
Yeah, I mean, they're guys that spend their whole lives, I mean, good physicists, brilliant physicists, just, you know, making these machines run.
Yeah. Yeah, then you get the papers where they have the name of every person who was involved in even the smallest way in the collaboration, and you have like hundreds and hundreds of names on the paper.
All I know it's taken lately to just calling the author like the D0 collaboration or something like that. And
okay, yeah, that makes sense.
Actually,
I remember I did a story on this once, and they at least used to refer to it as the A. Aardvark effect, because all these papers would be cited according to the first person in the alphabet, whose last name might be like Aaron or something with 2 A's. And there was some experiment at Fermilab, and I can't even remember. I think it was another one where they didn't find the Higgs boson. And I called up the first person on the paper to just, you know, because I was curious what he did. And he said, you know, it was just, you know, something in my graduate thesis, you know, had something to do with adjusting some component in the detector, and he didn't really know much else about it. And yet the paper was cited as his name et al. because of the alphabetical accident.
Right, and then physicists get mad if you refer to some paper by just the name of the lead author or something like that. It's like, well, you know, we list our authors alphabetically, or sometimes people kind of randomly, just, you know, change the listing of the authors.
Yeah, it's always been a tension in writing about science, because, you know, you really, you know, if you named all the authors and I mean, even when you go, you know, not just taking the extreme examples where you have hundreds, but even if there's like, you know, half a dozen, and, you know, a lot of people don't realize when we're writing these stories, you get down to the point where you're cutting down to the line so it actually fits into the newspaper.
That's right. And so if you got half a dozen people and their institutions, you're done. I mean,
right. And of course now they could just go online and Google it and then find this out. But
they would really prefer it if we mentioned who paid for the research also. But
oh, right. Yeah. Because that makes the sponsors happy, and then you have to say, look, you know, I've only got like 1,500 words here, and then you have to leave out a lot of science if you did all that housekeeping, and it's really not going to be very interesting to any of the readers.
Doesn't really help the reader, but
yeah. Well, you must get all kinds of, I mean, I used to get a lot more of this when I was writing more about superstrings and quantum gravity and things, but emails from people who have their own, you know, they figured out the grand unified theory of everything, or they've proved that ether really exists. And
yeah, I get those every day. Dark matter is a favorite one. I got one not too long ago from someone who actually said that he was a former physicist, and I opened it up, and it was full of all kinds of, you know, quantum mechanical equations and stuff.
Wow.
So I says, well, good luck, you know, but
yeah. Do you answer those?
You know, I try to answer everybody. Yeah, you know, thanks for writing. I mean,
But what if they just keep hounding you?
Oh well, it depends. If they're nice about it, what?
Yeah.
I might answer again, but I'm too busy to be anybody's pen pal. It is interesting. We get a lot of letters, really nasty letters, and what an idiot you are. You didn't know this and this, or you.
Right.
I always write back to these people, and they're always it's shocking. They're like, oh no, this is a human being on the other end of this thing, and they write back so contrite and apologetic, and no,
right.
I didn't mean to hurt your feelings. I love your stories, and I keep up the good work. It's just...
That's true. They're just flabbergasted that somebody replied, which is great.
I guess they're just trying to blow off steam or something.
Well, it does seem like there's a fairly significant number of people in the world who just sit down every day when the paper comes out, and I think they particularly do this to the science stories, and they just go over them, like I imagine them going over them with their finger, going word by word, and then reading along, and then Googling things, and then suddenly going, aha, I got a hit.
That's right.
And they find something that's either wrong or they think it's wrong.
That's absolutely right. I think there are characters in books, actually, who do this. With the New York Times, and they sit there and they go through and they look for misspellings or anything. And so sometimes you feel like you have a big target on your back.
It always makes me kind of nervous when I have a story coming out, and like the next day you go into the office and you open your mail queue and you just kind of wonder what you're going to find.
I do. With the internet, it's really wonderful though, because sometimes if people know that your story is coming, they can actually find it online before you can.
Oh yeah, it's so great to hear about an error before it's in print.
Things before I've seen them posted, they've already gotten them and written in to say that I misspelled their name or something. So it is a kind of a sort of free fact checking. Yeah, you can. I've always wondered if you could do this for a book.
Yeah,
somehow publish the whole thing online.
It seems like no matter how many times, I'm sure, we both write books and we get all these people to read them in advance, including experts and just regular smart people and friends. And still, there's little mistakes creep in.
Well, plus often then when they read them, they say, oh, I should have told you about such and such. Or what a really good story. Yes, Jesus. I
still get people writing in to tell me great anecdotes about Murray Gell-Mann.
Save them up.
It came out 11 years ago. So I guess I should do a website. But.
Well, you should, because he's still alive, so he's still generating.
Yeah, I see him every once in a while around Santa Fe, and actually it was Murray who. He used to say this, and he wrote it, I think, in the introduction to his book, The Quark and the Jaguar, that he imagined these people, he imagined them as men whose job was lighthouse keepers, and they were very lonely, and they would go read through books and mark all the mistakes and then write to the author. And he was writing how he dreaded that. And I thought, wow, if even Murray Gell-Mann, was nervous about that, we're in pretty good company.
Yeah, I think so. So you don't make a few mistakes, you're not trying hard enough. That's my theory.
Are you working on a book, or do you have any plans to?
Oh, I have a stock answer to that, which is I have an idea that I'm sort of nurturing and hoping it dies, but maybe it won't. Maybe I'll have to.
I wanted to mention that I think when I first really, long before I met you, I knew your book, Lonely Hearts of the Cosmos, which I'm holding up a copy, having pulled it from my shelves. And this, I just wanted to say, a lot of people know this, but this is just a wonderful, wonderful book about cosmology and it came out like in the early 90s, right?
91. It came out 20 years ago. That's really nice of you to say that, George. And I just read this. You are actually
it's one of these books you read, because I was writing books too. It's one of these books you read and you just think, oh God, this is so good. And still remember this one image. I think it's of Alan Sandage, the astronomer, in the cage at the telescope on Mount Wilson.
Right. Yeah.
Oh, it's just really, it just sends chills up your spine.
Well, right. I mean, you are one of the most graceful practitioners of our craft, and so I appreciate that.
Thanks.
That thought. I enjoy your work a lot. And, Alan Sandage just died last fall, and actually I was in Pasadena a week ago to speak at his memorial service.
Oh, I didn't. I missed that.
They had a great picture of him in the cage of the 200-inch telescope.
Oh.
Which must have been taken way up, above the telescope, and you could see the mirror of the 200-inch down below him, and he's sitting there in his flight suit, and he's got his CCD camera. It's not a CCD camera in those days, but between his
you're actually using your eyeball too, right? Yeah, I mean that's it's so direct,
all bundled up and ready for a night of business.
Wow. Yeah, in your book, I should say, it's kind of like it's sort of like a portrait biography of Sandage, sort of woven in with this whole history of dark matter and that whole era when they were discovering.
Which we now know is just only the beginning of the
beginning.
Universe.
Yeah. Well, you did a revised edition with a new epilogue, right?
I did. That was 10 years ago.
Oh God, time goes so quickly.
Because
that was recommended to me by. It was one of the. We mentioned earlier that there were the two teams that discovered the accelerating universe evidence.
The Perlmutter team and the Reese and Schmidt team, right?
Yeah, and a member of one of the teams was the Schmidt team was at Santa Barbara when I was there, and for some reason the subject. I think I was writing something about. Maybe that was the year that they got the No, they haven't gotten the Nobel for that. They're still fighting over in anticipation.
They've gotten every other prize.
They've gotten every other prize. I had some excuse to write about that incident in a Week in Review essay, and I was talking to the scientist about that, and he recommended the epilogue of your book is like you said. I think this is like the last word on who deserves the most credit for this and all this. And then he
tried to be very even-handed, so I'm not.
he Xeroxed it and put it in my mailbox. So. Quite a compliment. Yeah, I thought it was very. It seemed right down the middle.
We've always agreed, I think, or decided long ago that they would split the Nobel Prize.
Yeah.
I mean, if there's a Nobel Prize,
if there is, maybe it's something. Maybe there'll be a new
like that,
revelation. But a couple different times I've been just covering something else, minding my own business, and then I end up getting invited into someone's office, and they're lobbying me on one side or the other as far as who really discovered evidence of accelerating universe. It gets a little awkward sometimes.
Yeah, it's going to be a little uncomfortable.
It's kind of like it's not up to me.
They think our opinion is important or something.
I think they're vastly overestimating. Yeah. I suppose they might. You could make the argument that the weight of the coverage, and how that comes down. Because actually, now that I think about it, I wrote this piece when I was in Santa Barbara, and it came out, and I mentioned Saul Perlmutter just in passing, just kind of to connect. Because the thing wasn't even about or focused on the expanding universe, but in passing I mentioned dark energy and I mentioned Perlmutter, knowing full well, but not remembering while I was writing the sentence that there was this whole controversy in this other team, and then someone from the other team was there and just kind of went semi-ballistic.
a little warning light should have gone off in your head.
I know. I mean, now, it's one of those things, you go through your story with a fine-tooth comb, you're checking everything and checking it again, and then it's those things, they're not little simple declarative facts, and you write something that in and of itself was true and yet incomplete.
Right.
And that there's 6 or 8 people in the universe who will read this and be really mad because you put it that way.
You can't check the things that you leave out.
And of course, we ran the correction. So.
And you have book on cancer. Is it coming out, or is it?
Yeah, this is a real departure. It's the first. The only other time I've written about a biological science was a book about memory and how the brain stores memories, which actually I think came out that same year that Lonely Hearts of the Cosmos came out.
Was it
It was during the Iraq War,
of Memory?
the first Iraq War.
Is that it, Palaces of Memory? Or?
Yeah, the Palaces of Memory.
Yeah, great title.
Oh, thank you. And so now I'm, after writing all these physical science popular books, I'm writing a book on the science of cancer, and I'll actually have a piece in the Times. It's actually already in and just kind of waiting in the queue. It's one of these things where you go to a conference, and then by the time you write the story, the time peg, it goes from being at a conference last month to, or it goes from being at a conference last week to at a conference last month to at a conference this spring.
Recently.
Yeah. Oh, yeah. Now we're about out of spring officially, and so at a conference earlier this year. Yeah.
Yeah, because I thought that you had an article about that in the works.
Oh, I had one earlier, late last year, about antiquity of cancer and this evidence that they're finding that of cancer in ancient man and in relatives of man, like Louis Leakey found this fossil in Kenya in 1932 that was a jawbone that has what a lot of scientists think is a fossilized osteosarcoma, tumor of the bone. I was in London a few weeks ago, it's been more than a month now, and I went to the Museum of Natural History, and I got them to, I had to email ahead, and there was a lot of back and forth, and they dug this fossil out of a box somewhere in the basement, I guess. It was just so amazing to see this. It's like a 2-million-year-old fossilized jawbone of an early hominid, and just to look at this thing, and you can say, well, yeah, I could see that could be a tumor, but to my untrained eye, it could be a rock, and
right.
And then you have people who will look at it and argue over whether it's an osteosarcoma or Burkitt's lymphoma, or it's amazing.
I think it's amazing that, I was at this eclipse in Mexico 20 years ago, and we found there were a bunch of fossils on the beach, human fossils, and there was a doctor along on the expedition, and he was just like, pick up a little scrap of bone, and he knows what it is. It's just unbelievable to me. How they can do that, but
yeah. Well, it's just so great. Like covering science is sort of like from the point of view of an informed spectator, and I think we just think this stuff is so great and exciting, and then
I think we still have it's kind of a still underappreciated realm of human endeavor. It's not. We still have a lot of territory to ourselves.
Yeah.
Because
it's like if you decide you want to cover rock music, it's
people are afraid to enter into it.
Yeah. It's so great because it gives you license to meet all these amazing people like Alan Sandage and Saul Perlmutter and
all these stories waiting to be told.
Well, it looks like we're kind of closing in on an hour here. Is there something like you're working on now that you can give us a hint to look for, or is that all trade secrets?
It's all, it's all, as my boss, Corey Dean, used to say, you know it when you see it in the paper. And
right.
Corey
was out here.
I'm in a situation where the, last month is being shifted to last spring to recently.
Well, it sounds like it'll be something big when it comes out.
We hope.
Fingers crossed.
I'm keeping my eye on a lot of exoplanet business these days. And
that's a whole other thing we didn't get into.
It's sort of the opposite of string theory. It's lots of data and no theories, really. So every new observation is a surprise. So,
that's great.
It's a very rich field, and
it changed so suddenly. Like going from just wasn't so long ago where people were saying, well, we still haven't found the evidence of an Earth-like planet anywhere in the universe, and And people were actually, taking that into account in some of their speculations. And then suddenly we have a whole slew of them.
Yeah, how Earth-like they all turn out to be is yet to be proven, but it's very exciting.
And whether we get some signals from them. And
yeah, well,
thinking of Freeman Dyson again and his idea of the Dyson sphere, where if any civilization becomes advanced enough, it'll get to the point where it sort of exponentially overruns the energy supply of its planet, and pretty soon it'll need all the energy produced by its solar system or by its own sun.
right.
And then it would be natural that they'd do something like dismantle an unused large planet like Jupiter and reassemble it and make a sphere around the sun to capture all the energy. And that from our point of view, the sphere would be radiating heat, so we should be looking for these kind of dark, hot stars, and maybe there'd be intelligent universes inside them.
Right. Well, there was a Soviet theorist, Kardashev, who took this a step further, and he classes civilizations by how much energy they've been how many resources they've been able to command. So there's, and I forget, there's one type has sort of taken over their whole solar system, but then another type has taken over the whole galaxy, right? So those are type 2 or type 3 civilizations.
Star?
So we should look for those, but I don't looking around, it's hard for me to see how we're going to get there.
Yeah.
I would.
And if that's your measure of an advanced civilization, we're so primitive. It's like monkeys looking for quarks or something.
Yeah. Well, I think of the issue certainly looking for intelligent life in the cosmos. We have no idea what we're looking for, and might not even recognize it if we saw it.
Yeah. It brings up all those great philosophical questions of what intelligence is and what a pattern is, and is mathematics fundamental? But yeah, as far as some kind of algae-like scum on an exoplanet.
Well, that would be very exciting.
Yeah, yeah. That would be one of the big stories in our lifetimes.
It would be. I don't know if we'll get there in our lifetime.
Yeah.
Maybe in Enceladus. I have a lot of books for Enceladus.
Yeah. Yeah, let's do this again and talk more about exoplanets.
Okay, that would be fun. Yeah.
SETI.
All right.
That sounds cool. And meanwhile, we'll watch for your next story.
Okay. All right. You do that. Now I'll
Dennis.
watch for
Good
yours.
to talk to you.
Nice talking to you, George.
Okay.
Have a
Bye.
nice day. Bye.